Okay, so this is the video for conversion factors regarding SI units, because there are like SI derived units that are like Kelvin, that kind of fucking stuff, which is different. It has a different way of converting. So these ones in particular, though, as I mentioned, we're only talking about SI units. So what does that mean? SI units, or the SI part, stands for the International System of Units. And so this is like the modern form of the metric system, which includes the gram, the meter, the second. I guess it even includes Kelvin. But this, I guess that's where we got to talk about, as I said, some of these are going to have different conversion stuff than the units we're going to talk about, which they're all written down here. So this doesn't matter too much. It's just a good definition. I want red. Okay. And so there are some rules I've come up with that help me remember stuff. Because the conversion took a long time to figure out where does the number go and why does it do that? Why does it do that? So here we have positive exponents for conversion. So this is when you're going 10 to the third, 10 to the fourth, whatever number you're using to convert. When it has a positive exponent, this is what you want to do. So if you have a bigger unit, you got to put the bigger unit on the bottom because you want the big units to cancel out, and then you want what we have here is the little hashtag here that stands for the number. That's the number sign. So that number stands for the 10 to the third, 10 to the fourth, whatever that number is, but there's one here. And so in this case, you'll have the big unit. You want the big number, the big exponent to go with the small unit. And vice versa, vice versa isn't, the opposite units, but it's the same thing where you want that 10 to the power of 3, that positive exponent to be with the small unit. Whereas like if you have like negative exponents, say, just keep it simple, 10 to the power of negative 3, you want that, number that 10 to the power of something with the big unit for both cases. And so the way I remember this is you want the opposites. What's the opposite of a positive number? A negative number. We may not have a negative number, we do have a really small number. What about what's the opposite of a negative? Positive number. We may not have a positive number, but a positive number can also mean like a really big number, So that's just how I think of it. It makes sense in my brain right now. It might not make sense in the future, but that is how I remember it. I might be asking like, what's a small unit and what's a big unit in this case? What do you mean by that? And so that kind of goes into what we're talking about here with the units here. So in this case, for example, we'll have liters versus milliliters. Liters is the big unit, milliliters is a small unit. Because if you had 1 liter versus 1 milliliter, 1 liter is a lot more liquid than 1 milliliter of liquid, which is why liter is the big unit, milliliter is a small unit. Now we have over here, we have kilometers versus meters. The kilometers is the big unit versus meters is the small unit. Because 1 kilometer is so big, but 1 meter is much smaller than that in comparison. So kilometers is the big unit, meters is a small unit. So that's what that means, is in comparison with the other unit. If you had 1 of each unit, which one would be bigger? That's what it's based off of. That's how you know which is the big unit versus which is the small unit. You can also use this, handy dandy chart to help you figure out, what's the bigger one, what's the smaller one. It's not usually written like this. You usually have it, all in one row with like middle ground, which would just be like, the unit without the, the prefix. And then when you go up, you'll go up with like the deca, the hecto, all that stuff. And versus on the bottom, you go with the decin, the centimeter, the milliliter, all that stuff. You see what I mean? So that's how it's usually written out, which is kind of an easier way of visualizing it. But this one, the chart I have in here, has more numbers, more definitions, as well as the prefixes. So that's why I included that one. And so this will just, some people memorize this stuff. I've had a hard time with it. But it might be a good idea at some point to go in and like fully memorize this, because there might come a time where you can't have that stuff on hand, but anyway, that's what they mean. And then important thing to keep in mind say a problem asks you to convert from, I don't fucking know, millimeters to kilometers. Why not? You don't want to try and convert straight from milliliters or millimeters to kilometers. You could. I know some people who do, but I found every time I do that, it just comes out wrong. So the best way to do it is just you go one at a time. You'll start with that kilometer, and then you'll convert it to meters, and then you'll convert meters to millimeters. That's how you want to do it. That'll just make sure that, nothing weird happens. It keeps everything how it's supposed to be. As I said, some people can do it perfectly fine without doing that, but I just haven't had success with that. So we don't do that. And again, this is kind of a short chapter, so we're already kind of almost at the end. But now we have the example problems. So we're converting 500 milliliters to liters, right? So what we'll have here is we have the 500 milliliters, and we can set it up like this, because we know this is how we want it to be. Because if you had milliliters up top here, those would combine and you'd get milliliters squared because of the multiplication, because that's what they would be doing. They'd be multiplying together. But when you have the milliliters on the bottom, it cancels it out, and that's what we want. We want it to cancel out. So that's where we look at the chart, unless you have it memorized. Going from milliliters, you have 10 to the power of -3. Now remember what we said about the negative. We want negative exponents to go with a big number. And so in this case, the big unit or the big number is liters. So that means the 10 to the -3 goes with the liters. We put just the 1 on the bottom. And so as I said, milliliters cancel out. And we get our handy dandy calculator, and you go 500 times 10 to the power of -3. You get 0.5 liters. So in other words, 500 milliliters is equal to 0.5 liters. So that's how that works. And now here's, one where it's more complex. This is like what we just mentioned about wanting to convert from one to the other. So what we want to do is it helps sometimes to write a conversion plan. It just helps you remember what you want to convert and when. So in this case, we do centimeters to meters and then 2 millimeters. That's how that would be written now. Okay. So we have 35 centimeters. And again, we want the centimeter on the bottom to cancel out. We have the meter on the top. Let's go check back with our chart. What is centimeters? Centi. 10 to the -2. So remember, we have the -2. I wanted to go with the big. Right? So you have that. We know the centimeters cancel out. So we have the 35 times 10 to the power of -2. We get 0.35 meters. And now we want to convert again. And you can write it in a separate thing, but it's oftentimes just easier to just keep going. Now convert to millimeters. Go back to our handy dandy chart. What does milli mean? 10 to the -3. Goes with the big one again. In this case, that's on the bottom. So remember those meters cancel out. And then we have 0.35 divided this time by 10 to the power of -3. We end up with 350 millimeters. I don't know why that Grammarly thing is there. Get out of the way. And that's our answer, 350 millimeters. And so again, some people might combine that, where instead they would write, say 35 centimeters times 10 to the -2 or 10 to the -3, combine that shit. But as I said, I haven't had much success with that. It's never come out right for me. So I don't do that. Oh, come on. Let me select my color. Okay. And then we have another one of those ones, the compounded ones. So, why not? We'll write out that little plan again. Well, kilometers to meters to centimeters. Remember, kilometers is a big unit, so probably going to get a shit ton of centimeters. But the point of this is, with the centimeter and meter here, you're converting to two small units, two units that were smaller than meters, the main unit. These one you have the big one, and then centimeters is the smaller one, So it's just, wanted it to be like that. Okay, so we go back to where we were. We have 5 kilometers. Remember, we put the kilometers on the bottom and the meters on the top. And then we go back. What does kilometer do? Kilo, kilometer, 10 to the power of 3. This time we wanted to go with the smaller unit. So the kilometers cancel out, and they do 5 times 10 to the power of that, that positive 3. And you end up with 5,000 meters. This is already telling us that we're gonna have a shit ton of centimeters, but it is what it is. So now you have meters, you do it again. You want meters to cancel out, you put meters on the bottom. Put centimeters on the bottom, the top. So what does centimeters do, right? We already did it, but we're just gonna look again. What does centimeters do? Centimeter, 10 to the negative 2. It's a negative. 10 to the negative 2. We want to go with the bigger one. 10 to the negative 2, right? And then we cancel out those meters. And they do 5,000 divided by 10 to the power of negative 2. We get this crazy number. Let me count the zeros. 1, 2, 3, 4, 5. Okay. 1, 2, 3, 4, 5. There we go. So that equals this 500,000 centimeters. So 5 kilometers is 500,000 centimeters. So there you go. That's how that all works. So to recap, SI unit stands for the International System of Units. And specific when we talk about like grams, meters, those specific, or liters, that those have to do with what we're talking about here. So with positive exponents, you want the 10 to the power of something to go with the small unit. And then with negative exponents, you want 10 to the power of something which is negative to stay with the big unit or the bigger unit. And then to determine big unit versus small unit, it's how different they are. If you have one liter of a liquid versus 1 milliliter of a liquid, is 1 liter of liquid more liquid? Yes. Then liter is the bigger unit. Okay, so that's how that's figured out. And then when solving between one SI unit to another unit, that both have prefixes, solve to the unit without the prefix in the middle, and then solve to the unit with the prefix that you want after that. It just keeps things simple, make sure things are correct. Okay, so that is it for conversion factors.